So letter F is all about inflection points where it changes curvature. All right. I do have at the top of this whole page is just about, you can put everything on here that you want. If you want to pause the video, but see how it changes from concave down to concave up. That's a point of inflection. This is harder to see, but see how that's a little bit curved up, a little bit curved down. Stationary inflection, both of these two have to be true. You're both going to have a zero slope, and so they both will equal 0. I didn't really write any of this part down. Okay, this is on the next page. This is on kind of a summary. So everything in this first circle here, these are stationary points where the first derivative equals 0. Everything in the second one are inflection points where the second derivative equals 0. So that means what's in the center, both f prime equals 0 and f double prime equals 0. Okay, this we're going to need quite a bit of space. I did some dumb math when I was doing my notes on this, so hopefully I'll do better today. We're going to start with the first derivative. So we just use our power rule. 4 times 3, 12x to the third, 3 times 16, 48x squared, 2 times 24, 48x, and the 9 just goes away, your constant. Okay, we then need to figure out where the first derivative equals 0. There is a GCF of 12x. So first I'm going to divide everything by 12x. Now I can factor this quadratic. X and x minus 2 minus 2. All right, then I'm going to make my sign chart. So I have to find my x values. X equals 0, x equals 2, x equals 2. So 3x to the fourth, that's kind of just a W. Where my ends are both going up. It's really the middle that we got to figure out, because our W can look a lot of different shapes. Okay, so first of all, this exists everywhere. So it's a 0 slope at 0 and at 2. Technically over here we have negative infinity to positive infinity. We don't have any endpoints. So if I want in this interval, let's choose -1. If I plug -1 in for my x, I'm just going to plug it in here, because that would make this part negative, this part negative, this part negative. So a negative times a negative times a negative, that's negative. That makes sense because that means this first interval is decreasing. Now I'm going to plug in 1, and I'm going to label this, my f prime is negative. That tells me f is decreasing. Now let's plug in a positive 1. So that makes this positive, then this is negative, and this is negative. So that's a positive. So it's increasing. And then I'm going to pick 3 to plug in this interval. So positive, 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 still positive. So let's kind of think about what that's saying. I'm decreasing, zero slope, increasing, zero slope, increasing. Kind of that general shape. All right, this wouldn't be good enough for a sketch, but it's just enough to kind of give me a visual of what's going on. So this, it doesn't go back down in here because these were the same. So that means that kind of little double root there. Okay. Let's go ahead and do our second derivative, and then we'll kind of summarize everything all up at the end. Because I want to do the second derivative, do the same thing I just did on my first derivative. So first of all, take the derivative of the derivative. Okay. Then we set the second derivative equal to 0. We're going to follow exactly the same steps that I just did with the first derivative. All right. There's a GCF of 12. I'm going to divide everything by 12. I have to factor my quadratic. The only way to get 3x squared, 3x and x. Now, I'm going to do my little boxes here because this 3x, whatever I put here, gets multiplied times this 3. So I need to break up my 4 into 2 and 2. Let me show you how that works. 3x times 2 is 6x. 2x times x is 2x. And when I subtract them both, that's where negative 8 comes from. So let me kind of just get rid of that work stuff. All right, so what makes each one equal 0? This one's easy, just x equals 2. If you struggle with this one, you always can just make it equal 0, add 2, divide by 3. Okay, so now we're going to make our sign chart. So we're going from negative infinity to infinity. We're going to put on 2/3 and 2. Those are my 2 values that make my second derivative equal 0. So let's pick 0 in this interval, and I'm plugging it in. I'll plug it in here. This will be easy. This is always positive. If we plug in 0 here and here, that's going to be a negative times a negative. That's positive. So let's think about coming back over here. That means if f double prime is positive, f is concave up. Looking at this graph here, see how this is kind of concave up here to that point? So far that should make sense. Then I'm going to plug in, let's plug 1 in. Come up here, positive. If I plug in 1, that's 3 minus 2, that's a positive. 1 minus 2 is a negative. So positive times a positive times a negative, that's negative. So see, from here to here, this is concave down. And then I'm going to plug in 3. Positive, 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 that's positive, concave up. Okay, so now I'm going to come back up here. Notice how all of these change signs. Here's where We're going to talk about the difference between a stationary inflection, that's where both of them equal 0, and a non-stationary inflection where just the second derivative is 0. So this is kind of a difference. Okay, first of all, let's talk about, this is going to be a minimum where x is 0. So let me come back and erase this. So if I plug 0 into my equation, I get -9. This is going to be a minimum because it's the absolute lowest point on the graph. There is no maximum because my other spot where I have my 0 slope this is my stationary inflection point because both f prime of 2 equals 0 and, notice this, f double prime of 2 equals 0. That's going to be a part of letter B. So this is our only minimum. There is no maximum. So we're going to come down and classify. I don't know if I've got. So this, where x equals 2/3, is a non-stationary inflection. And where x equals 2 is a stationary inflection. So this can be a little tricky. Probably the big thing, notice how we change from positive to negative and then negative to positive. Probably the most important thing you've got to do is recognize that both x equals 2/3 and x equals 2 are both inflection points. If you're confused about the non-stationary versus the stationary, not a huge deal. Okay. All right. We're increasing, decreasing. That's where we come back to the sign chart for f prime. So it's increasing with all values greater than or equal to 0. So we can either say x is greater than or equal to 0, or we can say from 0 to infinity, whichever you're most comfortable with. Then it's decreasing, where x is less than or equal to 0, or you can say from 0 or from negative infinity to 0. Either one of those notations would be fine. Then we want concavity. Concave up, concave down. So I'm going to just come down here because I'm going to run out of room. So it's concave up, here, and here. So I'm going to say negative infinity to 2/3, union with, if I have two separate intervals, I'm going to union them, 2 to infinity. Concave down goes from 2/3 to 2. So I guess I like this notation better. I don't mind this so much if it's just less than 0 or greater than 0 for something, but if we're going from a certain spot or unioning, I like the interval notation like this. All right, and finally sketch the graph. All right, so first of all, I'm going to include 0, -9 as my y-intercept. All right. Then at 2, I don't know, they actually created a nice little chart. 0 was -9. At 2/3, it's -2.48. Because typically you're going to have your calculator with a problem like this. So just plugging stuff in. So 2/3, negative 2.48. So that's going to be down here. 2.7, that's somewhere up here. And then negative. Okay, so we're decreasing to 0, concave up, increasing, 0 slope, and that's where it changes concavity, and increasing. It's kind of ugly. I like this one better because it's kind of not so squished, but kind of similar, and that's our final graph. All right, example 16, I gave you a lot more room. You're gonna want your, I think you might want your calculator. I'm not sure. All right, let's think about what does it mean for the x-intercept and y-intercept. The x-intercept is where y is 0, and the y-intercept is where x is 0. So for letter A, we have just substitute 0 in for y. Now I'm going to add the e to the other side so it's positive. Now let's think, what is the inverse of e? How do I cancel e out? That's where we ln both sides, because ln has a base of e, so ln cancels out e. So at negative x equals ln 2. You can either multiply by -1 or divide by -1. Now, I would be okay with that. I will tell you that they might want you to adjust it. I want you to think about, this is like -1 times ln 2, correct? Your log properties, if you look at your log properties on your formula booklet, we could move this back to being an exponent. ln 2 to the -1. And then I could replace 2 to the -1 with 1/2. This answer and this answer are the same. It's just written in a different way. All right, letter B. To find the y-intercept, replace x with 0, and anything to the 0 power is 1. So our y-intercept is 1. All right, letter C. Show the function is increasing for all x. Increasing or decreasing is your first derivative. So when I take the derivative, y prime, the constant goes away. The derivative of e, now be careful, it's really the derivative of negative e. So I bring down the 2 cancels, I'm left with negative e to the negative x times the derivative of the exponent, which is -1. If I take negative e to the negative x times -1, my first derivative is just positive e to the negative x. Now, e to any power, this is always going to be a positive value. Anytime you raise something to a power, it's always going to be positive. Y prime is always positive. Therefore, y is always increasing. Now, if you get to this point and you're like, I don't know what to do, this says show it's increasing for all of x. I would literally just go to this next step and say, I know if it's increasing, it always has to be positive. So just write this down. Even if you get this wrong, you would just make that conclusion and show that you know kind of what you're doing. All right. So then D, show algebraically it's concave down. That means the second derivative has to be negative, less than 0. Now, you would get marks. Say that for this part, that means you wrote f prime is greater than 0. You would get a mark for that. But make sure it's not written in the question if you write down below that increasing means f prime is greater than 0, concave down means f prime double prime is less than 0, you're going to get points for that. Even if stuff that you did is wrong, that you would get points for. So always write that stuff out. Okay. Second derivative, y double prime. So that's just this part. We're taking the derivative of y prime. So the derivative of e is e times the derivative of the exponent. So now it's negative e to the negative x. This is always going to be negative. Y double prime, always negative. Therefore, y always concave down. Okay. Now, there's a lot of different things you could do for letter E. Let me kind of erase some of this here. When we look at this, 2, here. This 2 is our horizontal asymptote. And this is where I wish I were in person. So first of all, if we had e to the x, let me just do a quick little whatever over here. E to the x exponential graph like this. E to the negative x is flipped this way. That's exponential decay. E to the negative x. And if it's a negative e to the negative x, that's flipped over this way with my plus 2 being up 2. So it's going to look like that. Now, if we look back up here, we had our y-intercept at 1 and our x-intercept at negative ln 2. So here's our y-intercept at 1, our x-intercept at negative ln 2, and here's our graph. We could say for letter E that the limit as x approaches infinity of my graph equals 2. This is technically why my horizontal asymptote is y equals 2. It's approaching 2. To me, I think it's helpful just to think of the graph first, and then you can see your limits approaching 2. But I don't know if this helped here with thinking of e to the x this way, e to the negative x this way, then flip it. And that's section F.